simple menu. So let me just go back a little bit. So in iCn3D, you can choose to simplify your menu. Use the menu file, customize menus, and simple menus. And the simple menu will be sticky. And that means it will be remembered by your browser. And next time you open the browser, you will be still the same menu. But if you clear the cache, then the stickiness will be gone because it depends on the cache. Second, if you want to, let me see, I cannot show my mouse. Let me see. Pointer, laser point. Okay, now it's better. Okay. Second, if you want to revert back to all menus, then at the same place, you just change to all menus. You could even customize the menus also in the same menu, in the menu option, and click preferences. Then you can even, customize the menu. I also want to mention two other UIs. So there are about 6 or 7 menus. Last menu is help. Next to help, there's called toolbar. So if you click toolbar, then there will be icons listed underneath of the menu. The icons can be used to, they work as a shortcut to some basic features in the menu above. And I want to mention one very important concept in iCn3D is you have a selection. By default, all the items are selected, but once you make some selection, all the features, for example, you want to change the style, color, all the following features will be applied to your selected item. And if you want to, for example, change the style for everything, then you need to click this toggle to choose all items. The toggle all items or selection next to the help menu is used to switch between all items and select items. So this is important to remember because otherwise you might get lost. We do this way so that we don't need to specify the selection for each function. For example, you want to apply style, color, you don't need to mention the selection every time. So for each step, you have your selection, either your custom selection or all items. There is also a search button next to the help menu. It's used to search residues with one letter residue name. So for example, if you type CAAC, then it finds all the sequence will cysteine and then followed by alanine, and cysteine. Or you can also use wildcard, but this is convenient to search the sequence, especially when you open the sequence window through the analysis menu. So I want to mention how to load 3D structures. There are 3 ways. If you click iCn3D, somehow my button is not moving. Okay, my mouse is not moving. That's weird. Okay, anyway. So option 1, by default, if you open iCn3D page, you will see you can input a list of either PDB or AlphaFold UniProt IDs. And by default, if you just press a return button, it will show the biological unit. But you can choose the asymmetric unit. So biological unit basically is it works as the, it shows all the components, works as the biological assembly. But if you, sometimes the 3D structure, so biological unit is okay, but sometimes biological unit will miss some of the chains because that chain may not be part of the biological unit. So if you want to see all the chains, it's better to load a symmetric unit. There are some explanations about the difference between these two. And you can also append it to your current 3D structures. For example, if you open a PDB file already, then you can append this ID, the structures with ID to the current structure. Option 2, you can input. Let me try the pointers again. Oh, okay, now it's working again. So you can go to File, Open File, PDB files. You can also load the MNZIP files if the PDB file is not available. So you can load your structure files. The third option is you can search with protein or gene names. So if you could find the first option is search structure. And the first one is if you want to search PDB structure, then you can click there, go to NCBI structure database. And the second one is a shortcut. Basically, you can input the gene or protein names and search. It basically retrieves the first one with structure or AlphaFold structure. It's not a complete list. So this is a shortcut. You can try it out if you like. And if you want to see all the AlphaFold structures, then you can search AlphaFold UniProp database. It lists all the, for example, if you search TP53, it lists all the AlphaFold IDs. So these are the ways to load 3D structures. And once you load the structure, you can rotate with your left button of your mouse or click and drag. And you can, use keys to rotate as well. And to zoom, you can use the middle mouse, or to be convenient, you can press the letter X to zoom out and Z to zoom in. These are all lowercase letters, so you don't need to press Shift to get the uppercase. Just press the letter. And to translate, use right mouse. In tablet, you can use 2-finger click and drag. So iCn3D synchronize 3D structures and 2D cartoon or diagram and 1D sequence. So here shows one example. The analysis menu basically has all the important pop-up windows. Like the first one is sequence and annotations. It shows sequences, and these are annotations. And by default, it's a summary, but if you click detail button, it shows the all the sequence. And then 2D diagram or 2D cartoon shows the 2D, and define set shows all the chain structures and your custom selection. So it might be convenient to switch your selection. And there are some analysis tools listed here. I will introduce later. So by default, all items are selected. So if you want to select a subset in 3D, you can click select on 3D. You press the Alt key and click on the structure. It will select a residue by default, but you can change the switch, change the selection to select a chain or select a secondary structure. And you can click on define a set to select a chain or your set. And you can also click on the 2D diagram to select a chain. And to select a residue, it's actually more convenient to select in the sequence window with the details button pressed. So it shows all the sequence. you can just click and drag on the sequence to select whatever sequence you like. So you can select in 3D, 2D, or 1D. And once you select anything, the toggle becomes selection. And you'll see the menu style and the color becomes orange. It indicates that the style and the color will only apply to your selection. It actually, for analysis, will also be applied to your selection only. So once you do a selection, for example, I select these residues, and you can go to view, click the first one, view selection, then only your subset, your selection will be shown. And automatically, this selection will be saved with the default name, but you can change the name here. Or under selection there, you can also name the selection. So once you do selection in 1D, it shows up in 3D and also update in the 2D as well. So only the A chain, part of the A chain is selected. And so in this case, then if you apply the style or color will only be applied to your selection. Even without a view selection, the style and the color will only be applied to your selection. And here you can change color. Let me go back. There are many ways to change the style. So you can change the style for protein. Typically that's protein, but you can change the style for the side chain of the protein, or you can change style for nucleotide or chemicals, ions, water. And you can change your, the thickness. You can change the default value. So you can make the, the bond thinner or thicker. And you can show surface, and you can change the background. And color, there are also many ways to change the color. You can define unique color. You can just change to a certain color, or you can pick a color, or you can use the rainbow color or secondary structure color. There are different ways based on structure, based on the chain, based on residue, based on atom. Once you change the color, I didn't show it here, but a legend will show up like what are the colors for corresponding structure. So let's say you finished your work and you can, as Sandra mentioned, you can use share link and basically generate. Okay, let me talk about iCn3D PNG image first, then talk about share link in the next slide. So for example, if you load a custom PDB file, it cannot be worked in share link because then you need to remember the structure. That's too much. But you can save your work in iCn3D PNG image. So iCn3D PNG image for like 2 times or 4 times, it kind of increase the resolution. But typically you can use the original size and HTML. So the images might be look like this, and the HTML is a very short HTML. Basically, you can concatenate your HTML. For example, if you saved 3 structures, you can concatenate these HTML files to actually form your own gallery with all these 3 files. And so your gallery will have the dynamic, will have these images. And if you click this image, then it will show up your custom views dynamically. So it will be live gallery. And the PNG image can be loaded back to iCn3D. So, and it can also be saved in a server, and iCn3D can access that URL to read it. So this will apply to any kind of input. So this is more generic. But if your input is ID, and then you create your custom views, basically each step has a corresponding command. And iCn3D just concatenate all the commands together. So so the top part shows original URL. If you click File, Share Link, the top part shows the concatenated command separated by a semicolon, and all the commands, all the steps are listed here. But this was converted into a short URL through a Google Firebase. So you can just copy this short URL and paste to a web browser. It will expand to the full command. And it also shows it also shows commands to be used in Jupyter Notebook. You can just copy this command and paste into a Jupyter Notebook cell, and the same view will be displayed in Jupyter Notebook. So share link might be convenient if your input is the ID, either PDB ID or AlphaFold Uniprop ID. Okay, I think that's pretty much all the basic stuff I want to cover. And maybe I just simply quickly go through some of the advanced features, then we can answer more specific questions. So in the sequence window, the first line shows the protein sequence. Then all the rest will be annotations. You can click each specific annotation and it will show up as a track. For example, CleanVar and SNPs, it will show up as a CleanVar and SNP track. And so sometimes it's convenient to list all the annotations, as tracks, and you can compare them and see which residues are more, has certain features, functions. So the annotations can be retrieved. So you have the web display, right? But the data can be retrieved by Node.js script. So there's the file in this location called annotation.js. I actually forgot to paste anyway, I will send you the slide file, so all the links you can click. But basically, these are all in the GitHub page. And for example, if you want to retrieve the post-transcriptional modification annotation, you can just, when you use Node.js script, then you can just type node annotations.js. Number 9 is for the PTM, because there are many annotations. In the script, it describes which number is for which annotation. And you can also use Python script to basically get all the data in the web page. So you can also use the URL to retrieve the data. So the Node.js script is more fundamental, it's more powerful, but Python script can retrieve the data in your web browser. And then you can show the interaction in the analysis. There's a menu called interaction, and you can show what kind of interaction you want to show and select 2 sets in your defined set and show interactions with different display. In this case, with 2 lines. The first line is for first set. Basically, it's a ligand in this case. And second line will be the interacting residues. There are other ways to display the interaction. And also in the analysis menu, there's the called mutation. So you can specify the mutation for PDB structure or AlphaFold structure, and then show the interactions due to the mutation. It shows all the interactions, the common interactions, and different interactions. And you can click on the 2D to show up in the 3D. So I think some of you used this before, so yeah. And you can also use the Delphi potential to show the electrostatic potential either on the surface or as the equipotential map. So this is convenient. In just 2 clicks, you can show the potential. And we also have many alignment features. So the first step, you can find a similar structure. I mean, structure neighbor either use VAST plus, which search the whole PDB complex, or you can use VAST to search a similar chain. Also, you can use PhotoSeek to search against PDB or AlphaFold. Once you, so here shows examples to get the VAST plus, the similar structure complex. And then here shows examples. You can define the chain, or you can load a PDB structure and search fast directly. So basically, you find a neighbor and then show in iCn3D. This one shows if you load AlphaFold structures, then you can just click submit and it will search against the PDB database. And here shows the alignment. There are different ways to align. Most popular one is you align different chains by structure or by sequence or by your predefined mapping. For example, sometimes you want to define the alignment more specifically, so you can do that. And you can align protein complexes either by VAST or there's another way to do it here as well. Or you can align a sequence to a structure. For example, you do a blast search, you have many aligned sequence, and you can show the sequence alignment together with the structure. So, and we have 2 back-end alignment methods. One is called TM align. The other one is called VAST. You can try both. And another way to align them is you can load the structure first. So you load the PDB files, for example, and then you go to realign selection. So basically, it's a similar format. You can align by a structure or by a sequence. And then you select which chain you want to align. So once you click realign, then it will also be aligned together. So yeah, there are 2 ways to do alignment. I think that's pretty much what I want to cover. I'll go very quickly about the advanced features. If you use it and you can ask more specific questions, I don't want to go through too much details before you get familiar with it. Yeah, so I'm open for any questions.
Sorry, my dog was going crazy right there. Oh, okay. Yeah. Erica thinks it's running really slow, but you eventually got it loaded. You know what I think is going on? I looked at those structures, and those are big structures.
Yeah, for large structures, it might be a little bit slow, but if you see any problem, just let me know. I think, yeah, Chrome or Firefox, I usually use Chrome, but Firefox should be okay. But IE will not work. Edge, I think, should work. Yeah.
So there's a structure from Keith about are there limits based on the user's hardware as opposed to the servers at NCBI?
So I think typically there should be no limit on your user's hardware. But if you open like 10 tabs or 10 browsers with different analysis, that might require some, they might have some memory requirement. But if you open 1 or 2 tabs, I think should be okay. Yeah.
So it might your mileage might vary depending on how many tabs you have open, and maybe
yeah. Also depends on the structure. If it's a huge structure, it might use a lot of memory. Yeah.
Yeah, and I know the ones that Erica's talking about, and those ones are kind of big, and they
yeah,
can.
These are like medium to large, but it should work. Let me try. Let me try with the example Eric mentioned. See how it works. So
I have used these in the past and it worked okay. That's why I was using it as an example, because I had my students working on it. And then for some reason today, it just doesn't seem to be loading for us.
Okay.
The one that did load was, like Sandy had said, the more specific, smaller pieces. That did work okay, but yeah, well, eventually.
Yeah.
This is Lori. I have a question. If this is running out of NIH, they are now closed due to the tornado warnings. So.
So, okay. So basically, certain information was retrieved through the back end, but I think you should be able to. So let me show you. Okay. Can you see my screen?
Not yet.
Not yet. Okay. I didn't show yet. Maybe. Oh, let's share. Okay. Okay. So if you open iCn3D, okay. Here I'm loading these 2 structures. Let me see why they are not loading up. Yeah, it's a little. Oh, there might be some. Okay, might be some issues. Anyway, so if you go to retrieve by ID, and by default you can specify PDB or AlphaFold ID, but you can be more specific. For example, you can get the data from NCBI that rely on NCBI server. You can get data from RCSB that actually rely on RCSB server. And you can get AlphaFold data from, this rely on the AlphaFold server. So, you can also open your local files. So I would say for basic viewing structures, it doesn't depend on NCBI server. So for example, NCBI is totally down. You can, let me show you how there are certain ways to visualize structures. So it's in developer how to embed iCn3D. So one of the way is that you can use iCn3D locally. So you can go to iCn3D GitHub page and use the code button to download iCn3D and launch iCn3D locally by click this file in the district directory. So basically, you go here, get all the code, and the distribute directory has all the files you can run locally. So for example, I have one example let me see where it is. It's under here. So for example, I have different versions of iCn3D, and these are actually all local. So I go to district directory and I click index and see if I put my PDB ID. Right now it actually retrieves the data from NCBI, but you can load your PDB files locally. So yeah, it's not totally dependent on NCBI server. Yeah. Okay, I think somehow there's some problems, but when I load these structures, I think there's a bug. But let me do alignment. So I want to. Okay, in this case, they are loaded already. So I do a realign. They are colored by structures. I loaded 2 structures. If you go to define set, see the 6BSB is in blue and 6BXX is in pink. So if I go to realign by structure alignment, and if I select A chain and this A chain, so I just select align to A chain, and I click align. They should be aligned. Oops, something going on. So actually there's a bug. Yes. Okay, I see. I actually introduced the bug today. It's about the, yeah. Okay, so actually, you will see they are aligned because I try to get rid of the color legend so that you introduce a bug. But yeah, that's how it should look like.
We have a question about what the difference is between TM Align and VAST.
Okay, so TM Align was developed by Dr. John's lab, I think in University of Michigan, and it's a popular one, and it has a TM score. People usually use to compare the similarity, like between 0 to 1. If it's close to 1, then they are very similar. And VAST is alignment method developed at NCBI. It's based on the secondary structure. So, so I would say for more specific alignment, VAST works better than TM Align. But if these 2 structures are not so similar, VAST may not be aligned, but TM Align will align them anyway. So you can try both. Yeah. Yeah, they are all free to all users.
More questions? Well, we want you to get home, out of that tornado.
I'm at home already, so
okay.
It's fine.
Glad to hear that. All right. Well then, I will, everybody, you can go back to your rooms before you do. Tomorrow morning, I will have everything opened at 6 a.m. Eastern, and we will have kind of a main room session at 12 o'clock, or 11:45 to 12 o'clock Eastern time. And Lori Kilman will tell us, and her husband will tell us all about NIST CHO cells and about the NIST monoclonal antibody. And thank you so much, Jael, for coming and joining us.
You're welcome.
And if people have questions, we will relay them to him. So
yeah.
Send us.
I will fix the bug maybe in 10 minutes. Yeah, I just introduced this today. Sorry about that. Yeah.
Okay. Well, thank you.
Yep.
That's
Okay.
Swiss. Anyway, thank you so much for coming. And yeah, we hope you have a great trip. And people have questions about iCn3D. We're happy to relay them and send them
Yep.
along. And yeah, we really appreciate your time and help with this.
Okay. Thank you.
All right,
Okay,
everybody.
bye.
So yeah, feel free to get to work. There is tomorrow. It is the Zoom link. It says on Tuesday in Slack with the passcode. There's a passcode for tomorrow, and you'll find it in Slack in the schedule. And you can email me or message me if you have questions. And I guess I will go back to my room too. Or actually, are there any questions for me before I go back? All right, then.
But for folks in my room, I'm leaving. I think they're closing the campus. So have a nice day, everybody. Bye.
Thanks, Lori. Be safe.
And I'll be in our breakout room at what is that? 1:30 ET, 12:30 PT, 1:30 PT, 4:30 ET. There we go.
4:30 ET.
Yes.
Got to add 3 to everything.
Add 3. Okay. So see you in 15. Yes.
That sounds like a good idea. I'll take a 15-minute break too for people in my breakout room. And see you soon.